the reason behind this one? Why they are having this type of reactions here? How it is happening here? So in that case, what I will take a slide here so that I can explain here nucleophilic addition reactions here in a slide. Now, if I see something what happened, an aldehyde, a carbon compound I'm taking like this, R, C, double bond O, H, or R. Positive charge, partial positive, partial negative, because it's covalent bond, no? So put what? Partial positive, partial negative. Now, whenever if you observe what happened, a nucleophile attacks on carbon like this. Now it is sp2 carbon, right? Or correct or not, better? sp2 carbon. This carbon is sp2 because of having a pi bond here. It is having a pi bond, therefore it is sp2 hybridization. Attacks on which side? sp2 carbon. Now this carbon will get the pi bonds. No, the pi bond will be shifted over on oxygen here. Now we are going to get a structure like this: R, C, O, R, H, R. You take R. Now we are getting here nucleophile here. We are getting here O minus. Now this is the addition of nucleophile. Nucleophilic addition takes place in this. Now this carbon will be which hybridization, beta? Anybody? What is the hybridization of this carbon?
sp3.
sp3 carbon. Now
sp3.
Now in nucleophilic addition reaction, sp2 carbon converting into sp3 carbon. Now after that, what you have to add H plus to this one, or add a electrophile to this one. Add an electrophile to this one. Okay. Now what we get here simply RCH or R nucleophile OH. If it is hydrogen, we get most of the case 19% hydrogen. It will be OH. This is the product we are going. And this is the mechanism for what? Nucleophilic addition reactions, isn't it? In which sp2 carbon is converting into sp3. Because in MCQ you may get question like this. In nucleophilic addition, following change is occurring: sp2 to sp3, isn't it? sp2 to sp3 in this process you are getting, right? Now here, this is planar. Why? Because sp2 carbon definitely will be planar like this. In this way, it will be like this. On paper, it looks like this. Now we'll convert into what here? Tetrahedral nature. After addition product, what we are going to get? A tetrahedral product we are going to get, right? Next, the reactivity. If you observe here, what is the reactivity? Now we'll get here one thing. First of all, I will write here aldehydes are more reactive than ketones. This you write in your notebook actually. Aldehydes are more reactive than the ketones. Write down this one better. Aldehydes are more reactive than the ketones. What is the reason? Why aldehydes are more reactive when compared with ketones? This can be explained with the two reasons. I can explain this one with the two reasons. Aldehydes are more reactive than ketones. What is the reason? So I'm explaining with this example like aldehyde, RC double bond O H. One more I'm taking RC double bond O R. Now this is the ketone. This one is the aldehyde. Now we're getting a positive, partial negative, partial positive character, right? And also what partial negative character, partial positive character you are getting. Please, all of you, please note down this one better because it is not there in the textbook. So I'm writing on the PDF here. So all of you take like this so that it will be easy for you. You can write on textbook also like this by using pencil or whatever it may be. Okay. Now here, this R will be a electron donating group beta, maybe plus I or plus M group, electron donating group. Here also what happened? R is what happened? Electron donating groups. Electron donating groups. Okay. Now nucleophile is attacking here. Now nucleophile attacks where? On carbon side. Here it is attacking, or here it can attack, or it can attack here. Now because of steric hindrance, okay, because of steric hindrance here. Why steric hindrance beta? Left side, right side, bulk groups are there here. In that case, attacking on the carbon difficult here. So what I'm saying, due to steric hindrance, isn't it? attacking of nucleophile and ketone side is what difficult it is, isn't it? But here there is, you have any steric hindrance is there here? Here is free here. This part is free here, therefore it can easily attack it. This can easily attack it. It's difficult to attack it. Understood here? Any doubts regarding steric hindrance beta? Which are having steric hindrance, aldehydes or ketones beta?
Ketones.
Ketones are having steric hindrance. You see here, sterically, the presence of two relatively large substituents in ketones hinders the approach of nucleophile to carbonyl carbon than in aldehyde having only one such substituent, isn't it? Here only one steric hindrance bulk group is there. This part is free group. Here both side bulk groups are there here and here. Both side you are having bulk groups are there. That is the reason behind, isn't it? Attacking of nucleophile is getting what? Difficult for you here, right? So first reason is okay. So based on sterical hindrance, isn't it? Steric hindrance, ketones are having less reactive, correct? Like second point, if you observe here what happened, electron donating group here. How many donating groups are there in the ketone? 2 electron donating groups are there. Here and either side electron donating groups are there. Now what is the function of electron donating groups beta? What is the function of electron donating group? Yes, everyone is silent. Are you there?
The groups that donate electron.
They donate electron. Simple reason. What is the function of electron donating group? Means they donate electron. Electron donating group. Electron they donates. इसमें सोचने के लिए क्या बात है इसमें? Electron withdrawing groups they withdraw electron. Now here what is happening here? Only one group is electron donating here. Here two groups are electron donating. Now where we get less electron deficiency, here or here? Here or here? Where we get electron deficiency more? In all
Ketone.
Electron deficiency more in which case? Aldehyde or ketone? Please.
Aldehyde.
Just imagine this carbon, aldehyde carbon required something. What happened? 100 rupees it required. It required how many rupees? 100. It is also requiring 100 rupees. Correct or not? Right? It is requiring 100. Both are required 100 for paying the school fee. Right? Then one electron donating group, mother. So just imagine it's a father. This is a father. Father has given how much? 20 or 30 rupees are given here. 30 rupees is given to this student actually. How much is required actually? 70 rupees still required for paying the fees. Correct? Understood? Yes or no?
Yes, sir.
Next, remaining,
Yes, sir.
please speak out. Now again same, here also required 100 rupees. Father has donated 30 rupees. Mother also donated 30 rupees. Total 60 rupees were donated here. He required 40 rupees are required here. He required, after donation, he required how much? Aldehyde required how much? 70 rupees are required for aldehyde. For ketone, only 40 rupees are required. So which is having more deficiency of electron beta? Aldehyde or ketone?
Aldehyde.
Then nucleophile always wherever electron deficient is there. Now, if anybody wants, I'm a class teacher. So if I want to give money, to whom I will give money? To whom I will give money? Whoever having more deficiency, I will give money. He required only 40 rupees. No, he required 70 rupees. So I will give some money to this person, not this person. Actually, I don't give money, but just imagine that one. Right? So nucleophile attacks the carbon which has more deficiency of electron. See here, one is donating. Because of this, what happened? Electron donation in this case, what happened here? less your electron donation in the case of ketones will be more actually. Understood here? So what they are saying, electronically, aldehydes are more reactive than ketones because two alkyl groups reduces the electrophilicity, electron deficiency on carbonyl carbon more effectively. Here on ketone, what is happening? These two alkyl groups will reduce the electron deficiency, electrophilicity on the carbon carbon. Therefore, ketones are less reactive. In examination, they may ask this type of question. You write in your own words here. Don't write what happened. A student is what required 100 rupees. Sir is giving 30 rupees. Don't write like that. Write down in terms of what? Electron donating groups. Don't write father and mother like that. Understood here? Any doubts you're having the two reasons? Based on cumulatively now you say the first reason, second reason, steric hindrance and electrical reason here. So aldehydes are more reactive. Understood? Any doubts you're having in this one? Why aldehydes are more reactive? Yeah, what you are doing better? There are 34 students are there. Nobody is talking. This is not the correct way. Otherwise, I will stop the class. I show why. I will make a video on YouTube what happened, and I complete the syllabus. You people, what happens? Simply dumb in classroom. I don't want to take class. I don't want to take risk also. If you be silent, I also be silent. I will complete the syllabus. What happened? Are you there or not?
Yes, sir.
Yes,
You are not
sir.
speaking. Only
Yes,
Vinayak
sir.
will speak. What about others?
Yes, sir.
What
Yes,
about
sir.
others?
Yes, sir.
You don't have mind? Otherwise, I will complete the syllabus without asking any questions. Now, let me take one more question here. Benzaldehyde, whether it is having more reactive when you compare with what propanol. Here, actually, what happening here? RC double bond OH. This is aliphatic aldehyde. Aliphatic aldehyde. This part is called aliphatic aldehyde. And if I write any aromatic group like this, then they are called aromatic aldehydes. They are called what? Aromatic aldehydes. Now what they are asking, aromatic aldehydes and aliphatic aldehydes, which are more reactive, they are asking. For that one, they take an example. For aromatic, they take an benzaldehyde example for aromatic aldehyde. Benzaldehyde they taken. C double bond OH. Benzaldehyde they taken. This is called what? Benzaldehyde. Example for what actually? Aromatic aldehydes. Now one example they taken for aliphatic, a normal carbon chain, that is CH3, CH2, C double bond OH. This is called what? Propanol they taken. Okay, nothing but a aliphatic. You can take any alkyl group, ethanol, propanol, formaldehyde, isn't it? Butanol, pentanol, like that. It is an aromatic. Now the question is what? Which is more reactive towards nucleophilic addition? Where nucleophilic addition takes place readily. Now you are having again negative character here. You are having again here positive character. Now this pi bond and pi bond, they are alternate, correct or not? They are in conjugation, correct or not? These pi bonds are in conjugation. Whenever double bonds are in alternate like that, what happened? They undergo resonance like this. The pi bonds are in conjugation. Therefore, they undergo what happened? Resonance. So here, this bond will be shifted here and this bond will be shifted. Because of this, what happens is you see here now. What is happening here? Because of this resonance, you are getting double bond carbon O minus. Now tell me, where is the positive charge on the carbon? Do you have positive charge on the carbon? No. Because it got some electrons here. It got some electrons from the benzene ring here. So the decrease in the positive charge over the carbon because of what? Electron donation nature. Because of electron donating group plus mesomeric effect groups are there. Because of plus mesomeric effect groups. And these are also electron donating groups, but these are plus psi groups here. Plus psi groups are less effective when you compare with plus mesom. This is a resonance effect also. Plus resonance. Now, because of this, what happened? Are you seeing any negative charge over positive charge over carbon? No. So, what I'm saying here, in benzoyl, right, less electrophilic at carbon, less electron deficiency at the carbon atom. Because of what? Resonance structures. Because of what? Resonance. Isn't it? That is the reason what happened. It is less. Which one? Benzaldehyde is a less reactive than the propanol. So in examination, if they ask what you have tried, in benzaldehyde, because of the resonance, there will be decrease in the deficiency of carbon or electrophilic nature at the carbon. Therefore, nucleophile attacks less at benzaldehyde when you compare with what? Propanol. This is the, isn't it? 12.3. Next, we'll see some questions now here. We'll see some questions here. First one, we'll see HCN, addition of hydrogen cyanide. HCN, let me see. Addition of HCN. Very simple, I will write here. I will make a simple thing for this one. Addition of HCN, I will make here. Now, all of you, please take this one. All of you take your notebook, write down this one. All of you take your pen and write down this one. RC double bond O H. Okay. Reacting with hydrogen cyanide. Hydrogen cyanide. This is electrophile. H plus Cn minus is the nucleophile. So in nucleophilic addition reaction, always nucleophile attacks first, electrophile attacks later. In electrophilic addition, first electrophile attacks, later nucleophile attacks. So why I'm attacking on cyanide? Because nucleophilic addition. Now this pi bond is shifting like this. R C O minus, here it will be cyanide, it will be what here? Hydrogen. And after this electrophile, H plus is adding here. So we are going to get here R, C, OH, hydrogen, and what here? Cyanide. This is called what? Cyanohydrin. So in examination, they may ask, what is cyanohydrin? It is a product of addition of HCN to the carbonyl compound, in which two function groups are there. One is alcohol function group, other is what? Cyanide function group. Then it's having two function groups. What are they? Alcoholic function group. Other is having what? Cyano function group. That is the reason it is called what? Cyanohydrin. This reaction you can also write with ketone also. You can also write with ketone also. You will get same product. You write the ketone reaction also will be same reaction. You take one example here, CH3, C double bond O, CH3. Now, when you add HCN, write down the product here. What is the product here? Write down this one. What will be the product? It will be CH3, COH, CH3, and next one will be the cyanide. This will be the product. Very, very, very simple. What we are doing for this carbonyl, we are adding nucleophile and we are adding electrophile by breaking the pi bond. So this is called what? First reaction, reaction with HCN. Understood, everyone?
Yes, sir.
Yes, sir.
This one is a cyanohydrin. Getting here, cyanohydrin you are going to get here. So you practice this reaction with ketones and aldehydes. So aldehydes will react, even ketones also react with hydrogen cyanide. Generally, this reaction occurs very slowly with pure HCN. Therefore, what happens? It need a catalyst by adding a base, so that what happens? Cn minus B. Actually, what happens? Dissociating HCN into, isn't it? H plus is very difficult. So that is the reason when you add base, what happens? Whenever if you add a base, you will get the dissociation will be easy, so that Cn minus will attach easily. Generally, HCN when you add, no, it does not break into a Cn minus. So to break into Cn minus, what we are adding a base. So it need a catalyst actually. So a OH minus a base, a KOH or NaOH we are adding, which makes Cn minus readily, isn't it? Here, this is the point actually they are mentioned. Okay, right. Next, second one, if you observe addition of sodium hydrogen sulfate. Sodium hydrogen sulfate. How to write sodium hydrogen sulfate? This is called sodium hydrogen sulfite beta. It is called what? Ite. When you write SO4, that is called 8 beta. This is 8, right? When you write SO3, this will be called ite actually. This is called what? Ite. So you have to remember these differences actually. Identify this difference here. Now what is happening in this case? How it is attacking actually here? Now, if you observe in this case, what happened? Both aldehydes and ketones will form product in this case. Now, how to make this one? I'm writing here C double bond O. Now, how to make this one? We'll do one thing here. Na plus I'm writing here. HSO4 minus 3 I'm writing. This part will be what actually now nucleophile, right? And this part will be electrophile. Now what I'm getting after addition here? C, isn't it? This will get SO3H. Don't write HSO3 minus. SO3H actually. This bond is getting with sulfur, not with hydrogen beta. I will never have two bonds. Remember, hydrogen will have only one bond. So it is having with sulfur. Understood here? Again, I'm drawing here. Just this is with what? Sulfur, SO3H. Hydrogen already got a bond with this oxygen. So second bond you can't place here. So this is with sulfur. And here it is what? ONE. Isn't it? So in this way we are going to get. After this, what happened? No, a proton transfer is taking, because acid, no, this part is acid, no. What is the function of acid? Anybody? What is the function of acid?
Release of H plus.
This H plus will now transfer to this, because acid will release H plus, it will move to this one. Now what happens here? Carbon here with OH here, this will get actually here SO3 Na. This is the product. This is called what? Bisulphate addition product here. Bisulphate addition product here. Okay, again it will be converted back into by adding base. If you add any base, what happen? It will convert into again carbonyl compound. Otherwise aldehyde here. Both aldehydes and ketones will react like this. But important thing is this useful for the separation and purification of aldehydes. Why? Because we can again regain the aldehydes, correct or not? We can again regain. So in this reaction, what happens if you perform this reaction here, we can remove the impurities here. So in that case, again, if you add OH minus, this will get a pure form. In backward reaction, we get the pure. That means what happened? To get the pure form of aldehydes, isn't it? We will use. One more thing here, what happened? In this case, we can also separate aldehydes ketone with lower membrane, isn't it? So why? Because what happened? See, aldehydes are more reactive when compared with ketones in this case reaction, right? Next, third part, addition of Grignard reagent. This already we have discussed here. This part already have discussed. Again, I am writing on this this part. We already discussed this one. Okay, this is visible for you better. Formaldehyde will definitely will
Yes,
alcohol. Higher aldehydes will give secondary alcohol. Ketones will give tertiary alcohol. Already we discussed this one. Anyhow, again I will write because these are very, very important. Just I will make this reaction. If you have any doubts, you can watch the previous video. Preparation of alcohols by using the Grignard reagent. Watch the video preparation of alcohols by using Grignard reagent here. Now let me see again. I will explain this one by taking one example here. Formaldehyde HC double bond OH. Now I have taken Grignard reagent CH3MgBr. CH3MgBr. Now this is a nucleophile attached from the carbon side. So we are going to get CH3 CH2. Now this pi bond is shifted over here. You are going to get O minus. Add H3O plus. H plus in presence of water. You are going to get here what? CH3, CH2, CHO. You are going to get the aldehydes. Now formaldehyde only forms aldehyde. If you want to get aldehyde, we have, sorry, just a minute. OH, sorry, just a minute. OH. Primary alcohol. If you want primary alcohol, we need formaldehyde. Okay. Only formaldehyde will produce the primary alcohol. Next, any aldehyde except formaldehyde, if I take CH3 C double bond OH, any aldehyde I have taken except formaldehyde, I have taken again CH3 MgBr. You can take any Grignard reagent. Again, it will attack here. CH3 CO minus H, and this is attacking, we get CH3. So when you add again H plus and water, we are going to get CH3 CH OH, and it is CH3. This is called what? Isopropyl alcohol, secondary alcohol. And finally, if I take what? Ketones. Now ketones with Grignard reagent will give tertiary alcohol, CH3MgBr. Again, it attacks at this position. We are going to get CH3 CO minus CH3 CH3. Add H plus here. We are going to get here tertiary alcohol. This is called what? Tertiary alcohol. So we got tertiary from the ketone, secondary from aldehydes other than the formaldehyde, primary from the formaldehyde. So this is already be completed in the preparation of alcohols by using the Grignard reagent we discussed in the alcohol chapter. Right? So here you practice this. Don't say something, it is already there. No, don't leave this one, because these are very, very, very important reactions in conversion science. Next, the fourth one, let me see here. It looks what happened lengthy, but we'll make this one into very simple one. Addition of alcohols, I will make this one into very simple one. So how the reaction takes place, addition of alcohol here. First of all, what happened here? We'll see this reaction in a slide like this. Now take aldehydes or ketone. You can take reaction any with. So I'm taking something but R, C double bond O, H I have taken. You can take even ketone. You have to practice with ketone now. Take an alcohol. How alcohol will react with this one is a nucleophilic addition reaction. Takes place in presence of dry HCl. Okay, this is a HCl. Will you compulsory you have to use as a catalyst structure. Now here oxygen lone pair attacks on the carbon, same like that. The previous mechanism what we followed. R C O minus hydrogen, and here what we get here ROH. Now lone pair of oxygen donated to carbon. Now oxygen get positive charge and negative charge better. Now oxygen will get positive or negative charge?
Positive.
Very good, beta. Positive charge we are going to get here. Now having positive charge on more electronegative is highly unstable. So what happens here? The bonding electrons here, this is the bonding electrons here, are taken by the oxygen. Now hydrogen is removed as H plus here. Now because of this, what we get here? R C O minus hydrogen OR. OR. After that, what happened? This H plus you can add here. This H plus you can add here. Where here? So we are going to get actually R, C, OH, and H I am writing, this H I am writing here, and OR I am writing. Now again, this is having two functional groups. This is which type of functional group at anybody? Which type of functional group here? This is what, which type of functional group? Anybody? What functional group we can call that one? Yes? Very difficult.
Ester.
Very good. Ester linkage or ether linkage beta? Ether or ester? Carbon, oxygen, carbon. Which type of linkage beta? Ester or ether?
Ether.
Ether.
Linkage. This is called ether linkage. It is. So it is having ether function group. This already you know this one. This is what? Alcoholic function group. Again, here also we are getting two functional groups here. Alcohol and ether functional group here. Okay. Now, again, take second mole of alcohol. This is the first mole alcohol I have taken. Now, second mole of alcohol I am taking here, ROH. Now, second time I am doing the reaction. Now, here, this lone pair again attacks here, and completely the OH will be removed here. Completely the OH will be removed here. So, what we are going to get here, R, CH, OR. Okay. And here also what happened? ORH. Again, here also the lone pair of oxygen given to carbon, oxygen is got positive charge here, and we got here actually what? OR here. OH is removed here. Completely OH is removed here. This part is removed. So we attack. And again, these bonding electrons are taken by the oxygen. Hydrogen is removed as H plus here. So finally you are getting R, CH, 2 times OR. OR and OR. Now this is coming from which group? Aldehyde, no. So we call this one what? Acetal. We call this one as acetal. Okay, this is called acetal. Now again, if you do hydrolysis reaction, what happens here? That is not required in the syllabus, but anyhow, what do you do? If you do hydrolysis reaction, what happens here? The same thing. If you do hydrolysis, add some water to this one. Now what we get here? R, CH. Now OR will convert into here OH. Again OH. Again, a carbon having two OH groups is highly unstable. So what happens here? This bond will be shifted over here and the OH will be removed here. So definitely you are going to get the same thing we are going to get. The same thing. What we started here, that is become. Now we may ask this question here. We may get some question also here in examination. This reaction is useful for the protection of aldehyde. Why? Because I want to do some reactions at here. I want to do some reactions here. I want to do some reactions. Here I want to do some reaction. This should be protected here. In that case, what I have to do? I have to add 2 moles of alcohol. First mole alcohol, second mole alcohol. I will get acetal here. I will get an acetal. Then do reaction at here. Then do the reaction at here. After that, the reaction is completed. No, add water, and this will again convert into what actually here? Aldehyde. So here we regain this part. Okay. So why? Because if we do any reaction here, so this is also involved. This part also involving here. To prevent this one involving in the reaction, what we are doing? First of all, add with alcohol. This will be protected here by what? Acetal, like this. Now, how to get the ketal beta? How to get the ketal? Very simple. Put here R now here. In the place of R, this will be now ketone here. Now, if you take ketone, we get the ketal. If you take aldehyde, we get the acetal. Now, what we get here? We get R here. If you take ketone, we get R here. We get here also R here. Okay. And we get here also what happened? R here. And here also we are going to get the R like this. Like this. Very simple here. Okay. If you have any doubts, that means you can ask me. Otherwise, in writing the mechanism, you watch the video again. Once it is recorded, what happened? Watch this part. Definitely it will be understood for you, that mechanism. But in examination, what happened? Writing this mechanism is very difficult for us, right? That means very difficult means what happened? Remembering this lengthy mechanism is very difficult. In that, what happened? I will make this one very simple for you. How to make for this one very simple? How to make this one acetal like this? Directly, I can write like this. How? Let me see. Very simple. RCHO. This we are converting into what? Acetal. How to convert this one? By using what? 2 moles of alcohol groups. What we are adding? 2 moles of alcohol. Now, very simple. Now, 2 moles of alcohol means shall I write like this? Just a minute. One more also I am writing. For our understanding, I am writing 1 mole. How many moles I have taken? 2 moles. Now, remove here 2 hydrogens here. Now, take 2 OR here. Understood? And take oxygen outside here. Oxygen to hydrogen. Water will be removed. Understood here? Remove hydrogen, remove oxygen. Put 2 OR groups here. You will get the answer. We'll get done. We'll take one more example. Ketone I will take example. RC double bond O. Now what I'm taking? Alcohols. Okay. Now what I'm taking? This hydrogen I'm removing, and this complete oxygen I'm removing. So this hydrogen I'm removing, this oxygen I'm removing. Water is removed. Now these 2 OR groups I'm adding here. Warrior. Very simple or not? Tell me better, very simple or not? Understood? So in examination, no need to write everything here. And one more thing here, when you add first mole of alcohol, you see here, when you add first mole of alcohol, you got alcohol is there, you got ether also there. When you add first mole of alcohol, this is called what? Hemiacetal also we can call. Hemiacetal. If it is aldehyde, hemiacetal. If it is ketone, that is called Hemiketal, we can call this. This is also important. They ask in examination, what is hemiacetal? What is the definition of hemiacetal here? Having what? Alcohol and ether linkage is nothing but ether linkage and alcohol. They are called nothing but actually hemiacetals. Understood no? How to write? Very simple. RCR. Double bond O is there. Remove this one. Double bond. Put OR here. Completed. You got the product here. Understood everyone? Any doubts you are having? No doubt. Now, we'll take what? Ethylene glycol now. I will take what? Ethylene glycol now. If you don't use that type of shortcuts, it is very difficult for. Otherwise, you have to use mechanisms here. So now I will write one simple molecule RC double bond OR reacting with ethylene glycol. Now how to make the product for this one beta? What we have to do? Anybody? How to make the product for this one? How to make the product? How to make the product?
We have to remove double bond O.
Bhuvaneshwar, yes?
We have to remove.
The hydrogen like this. You write, all of you write down. Remove hydrogen, remove oxygen, remove this oxygen. Now I am writing like R, isn't it? C R like this. RCR. I remove the oxygen here, no. Now what I have to add these two. Oxygen, CH2, oxygen, CH2 like this. You got this product actually. You got this product, isn't it? Otherwise, if you do want to do the mechanism, you can do this with mechanism also. You can get this product here, this one. Ethylene glycol, you get it. I think what happened, understood for everyone this product. Remove hydrogen. Okay, remove what happened? Oxygen. This one you connect here. This one. You just write on the textbook also, you can make like this. In textbook, Remove hydrogen, remove the oxygen here, and bond this oxygen with carbon, you will get this protection. So for this one, dry HCl we are using here. This the HCl gas we have to use compulsory, isn't it? Right. Now this reaction useful for which, for what purpose, beta? To protect the carbonyl compounds, isn't it? The gem dialkoxy compound is nothing but called gem dialkoxy, means this part. How many alkoxy groups are there? 2. Therefore, 2 alkoxys, dialkoxy. And same carbon, gem dialkoxy we are calling as acetal. If it is ketone, this is called what? Ketal. If it is, how it is called ketal? If you take this one as acetone. Ketone if I take ketone, that will be acetone. Next we'll move to what here? Addition of ammonia. Now what I will do here, all these reactions I will write here. So what happened, I will cut this video at here only, so that I will make one more video here. But because of remaining reactions or looks for similar reactions.